Hello everyone, my name is Ian Holderman, and today we'll be learning about angle relationships in parallel lines crossed by a transversal. So first, what is a transversal? A transversal is a line that intersects a pair of parallel lines. Is this useful? Definitely is. This simple geometry is seen in many places throughout the world of engineering. Often engineers are expected to calculate the angles of ramps or launches, and we use this idea of transversals to calculate the angles we need. For example, this ramp here in the picture is an idea of a transversal plane, whereas the landings at the top of the stairs and the bottom of the stairs can be seen as parallel planes. And if we simplify that down to 2D, 2 dimensions instead of 3 dimensions, we can model that as parallel lines crossed by a transversal. So great, but how does it work? Well, you only need to remember a few special cases. In the supplementary angles and vertical angles, alternate interior angles and exterior angles, and corresponding angles. And right off the bat, it sounds confusing, but I promise you, it gets easier. It's really simple. So, what are supplementary angles and vertical angles? Supplementary angles are a set of angles that form a line, which is 180 degrees when they are added up. Like two 90-degree angles, because 90 plus 90 is 180. Or one 20-degree angle and one 160-degree angle. When you add those up, that's 180 degrees, and they form a straight line. Vertical angles are angles formed by the intersection of two straight lines. They are angles that are across from each other, not adjacent. This X has two sets of vertical angles. Can you spot them? So, with these parallel lines crossed by a transversal, we will have 4 pairs of vertical angles. And I'll give you a second to take a look and see if you can find them. So remember that vertical angles are the angles directly across from each other. So angles 1 and 4, angles 2 and 3, angles 5 and 8, and angles 6 and 7. And I've color-coded them for you with these colored circles. It's important to remember that these angles are actually equal to each other. So in this parallel lines crossed by a transversal, we'll also have 8 pairs of supplementary angles. And supplementary angles are those that, when you add them up, they equal 180 degrees or they form a line. I'll give you a second. So the first 4 are angles 1 and 2. So when you add up angles 1 and 2, they form that parallel line right there. And the same with angles 3 and 4 on the other side. When you add those up, those equal 180 degrees and form a parallel line. Angles 5 and 6 and angles 7 and 8 are similar. But you can also do it for the transversal, which is why there's 4 extra pairs. So angles 1 and 3, angles 2 and 4, angles 5 and 7, and angles 6 and 8, when you add those angles up, those are the angles that add to 180 degrees. So now we have alternate interior and alternate exterior angles. So the exterior angles refer to the angles that are outside the parallel lines, while the interior angles refer to those angles that are inside the parallel lines, in between them. So alternate interior angles are the angles that are equal in between the parallel lines. They are called alternate interior angles because they are the angles in each pair that are on opposite sides of the transversal. And the same thing with the exterior angles. They're outside the parallel lines, but they're on the opposite sides, and they're equal. So let's go through an example. So there are 2 pairs of alternate interior angles, and there's only 4 angles, so 2 of these are going to be equal. So what I said was that they will be on opposite sides of the transversal, so angles 3 and 6, and angles 4 and 5. And then the same thing with exterior angles. There are 2 pairs of these. So which ones would these be? They're on opposite sides, and they're on the outside, and they're equal. So it's angles 1 and 8, and angles 2 and 7. So now we have corresponding angles, and corresponding angles consist of one exterior angle and one interior angle that are actually equal to each other. And using the angle relationships that we have, we can actually define which ones are the corresponding angles. So what we know is that angles 1 and 4 are equal to each other because they are vertical angles. And we also know that angles 4 and 5 are equal because they are alternate interior angles. So therefore, angles 1 and 5 are equal to each other, and indeed, that is our corresponding angle. We have one interior and one exterior. So similarly, angles 2 and 6, angles 3 and 7, and angles 4 and 8 are the other three sets of corresponding angles. So using these angle relationships, we can prove that angles 1, 4, 5, and 8 are all equal to each other, and angles 2, 3, 6, and 7 are all equal to each other. And if you add any of the purple angles to any of the yellow angles, you will have a supplementary pair, and that'll be 180 degrees.